Okay, I'm going to go over some of my lectures. This one is and, not mod. A lot of people don't know what the and operator does. Rather, if you want to take the remainder divided by a power of 2 minus 1, you can use the and. So for example, let's say you want the remainder divided by, what is that, 1024, you take 1023. Anyway, so this does a comparison in execution time. It's really, really difficult to measure execution time. When I was young, we used to measure the loop overhead. Then we would measure one code, and then we would measure another code. However, you can't do that anymore. I think all the old people don't know. Sometimes I encounter people who don't realize things have changed. Anyway, not that that's relevant. Anyway, and not mod. So I don't know who knows what the timing is, but it's faster. So you might want to make an array of 1024 or 512 or 256. If you make an array that's a power of 2, then array access calculations are faster if it's multidimensional. Anyway, that's a shift that's related to and not mod. You can multiply by a power of 2 by saying shift. Anyway, it's pretty elementary stuff. Just today I got somebody who was looking at my code and thinking I didn't have a floating point unit. So this is doing fixed point math. What do we got? The integer version took 0.6. The float version took 3.0. That's with my compiler. Integer math is still faster, but not by much. Integer math is faster than float math. And let's just say you can store fractions in integers if you think about them. How do I put this? Fixed point means, this is an example. At Ticketmaster, we did money calculations with integer pennies. So 10,000 was $100 because it was. So we did our math not with float. We did our money calculation not with float, but with integer pennies. Normally you do a power of 2, but that's just an example of integer instead of float. Here's some more. I have some examples with some timing. Basically, I did my graphics library with integer fixed point. They call that fixed point if you hold pennies instead of. Anyway, now this shows the overhead of updating the screen. We're using 15% of our CPU just in order to copy a changing pattern to the screen. It used to be more dramatic. Oh well, 15% is not that much. I have problems with graphics, but that's because it's the 3D calculations, not the. I can only blame 15% on the overhead. This is just demonstrating software interrupts are slow. This compares a software interrupt to a regular call. A software interrupt takes 500 cycles because it has to change. It a software interrupt does a lot of stuff, like changing stacks and doing stuff. So in other words, interrupts sound really neat until you learn they're slow. So in my operating system, it's ring 0 only, which means I never need to change privilege levels. And basically, I always use call instead of an interrupt. There's sysentry, syscall, something like that. Syscall, I don't use that. I never change privilege levels. So it's a no-brainer that a ring 0 operating system is faster. I get people that play dumb. You know, come on. They're trying to brainwash people because the CIA doesn't like ring 0 only operating systems. So it's crazy brainwashing. So I just showed my compiler. How about my graphics library? Oh, this won't show up on the video. I made a little graphics library that demonstrates how to write to VGA memory, how to draw lines with, you calculate the slope and then do fixed point. Everyone else does that other algorithm, but this is what I thought was most natural. I do circles by using complex math. Every electrical engineer knows about complex numbers, and rotating a vector a few degrees at a time to draw a circle is pretty easy to understand. Here's the two critical: sine, cosine, cosine, sine. Anyway, negative displacement. My compiler will do most okay, so the x86 assembly uses signed byte. So from 0 to 7F is 1 byte, and then above 7F is 4 bytes for each. You can see these 4 bytes here. 1, 2, 3. I forget. Anyway, there's 4 bytes. 1, 2. And anyway, so if you make your structure pointer so that you can use negative offsets, then you can get shorter code. I don't know if it's any faster, probably not. In the old days it would be faster. It fits in cache a little better, but that's not gonna, oh well. So minus 128, $ equals minus 128. You can reset the program counter in a structure. I don't know what you want to call it, program counter. Anyway, optimization, what is this? I was just showing that it's pretty crazy for all the old timers to see how instruction timings are. So the second and third are about identical. Loop 2, loop 3, loop 2, loop 3, optimize 1, 2. So this and this are about identical. Oh well, basically you can play with optimizations on your own and try and figure out how modern processors work. Okay, this does PCI interrupts. I can hit the keyboard and I can see this count increase. I don't do any PCI. I do pick interrupts. That's the old-fashioned kind. PCI is way too complicated. The problem is, it's easy enough to do it on one machine, but let's say you got 10 different machines. It's beyond the scope of anything I want to do. It's really, you can share lines, there's different buses, it's a mess. Anyway, page tables. So I identity map everything, but I made a couple demos in case you want to play with page tables. So this just this maps the screen twice so that you get a repeated chunk of screen. This this has a handler. I made my own compiler with my own. Let's go ahead and see what page fault. Let's unassemble function page fault. It ends with an IRET and it saves all registers, including AX. That's like the old-fashioned compilers. You have an interrupt keyword. So my operating system is for playing. You can play with page faults. How cool is that? Yeah, this plays. You can play with ring 3 if you want to. I set up. I don't use ring 3, but I made some task registers that lets you play with ring 3, or code segments for ring 3, something like that. GDT for task registers for ring 3. Screen memory, okay, that's just an example. Spinning, I tried to explain that if you use yield, it doesn't chew up CPU. Anyway, there's such a thing as cooperative multitasking. The CIA is trying to brainwash people. I went to the wiki and it said infinite time slice. That's what cooperative multitasking is. Well, what it means is you give up control voluntarily, and it's just as it's actually easier to write programs, some programs, although after time sometimes it's easier to have. Anyway, if you have no malicious code, you can do cooperative multitasking. Uncached, I don't think this works anymore. This marks some page table entries as uncached, and then it's incredibly slow without cache. And my 64-bit ASM quiz. This is pretty cool. I love giving this. Earlier I was talking about 2 meg page tables. On 32-bit it's 4 meg. This is granularity of the page tables. So I wrote an assembler and compiler, so I got the intimate details of 64-bit mode. I learned such trivia as R13 instructions take 1 more byte in certain addressing modes because they're an alias or they're related to RBP and they use a different modder. Anyway, okay, so how about that?